Dear class, I'm standing still on this couple of pages as in the previous lecture, and also on page 80, 81, 82, 83, 84, and that all had to do with the counting of bacteria. Now let me tell you, as I said in all my other videos, there's no technique that is 100% accurate. And I want to show you, why do we need dilutions? And you will wonder, say, yeah, what is going on this page of mine? But I'm going to explain to you, it's actually very simple. If you see here, I've got a water sample. In this water sample is 1 million bacteria. If I take 1 ml and I grow it on a nutrient agar plate, I will not be able to count that bacteria. For that reason, I'm going to make dilutions. And I decided I'm going to make dilutions up to 10 minus 5, and you can see that all of them is 9 ml sterile dilution waters. How do I do these dilutions? I take 1 ml from my sample, and I add it into the first bottle. So this is a 1 ml and 9 ml. It's a 1 in 10 dilution. So this is a 10 minus 1 dilution. And if I go from here to the next dilution water, do you agree with me? This is also a 1 in 10 dilution. And 10 minus 1 plus 10 minus 1 gives us now a 10 minus 2 dilution. If we go from here to the next bottle, 1 ml, that's another 1 in 10 dilution. So 10 minus 2 plus 10 minus 1. So we made now already a 10 minus 3 dilution. A 10 minus 3 dilution from the original sample. And so we carry on. Take another 1 ml. Over to there, it's another 1 in 10. It's a 10 minus 1 dilution. 10 minus 3 plus 10 minus 1. So we are now at 10 minus 4 dilution from the original sample. Now I carry on and making 10 minus 5. Majority of techniques or methods will tell you, class, take a water sample and make a 10 minus 5 dilution. That's what they're going to tell you. So how you're going to get to 10 minus 5 is up to you and what is being supplied to you. Now I want to show you why. I said no, I cannot count 1 million bacteria on this sample. If I've got 1 million bacteria per ml, remember this bacteria is per ml into this water sample. If I take 1 ml, it's a 1 in 10 dilution. What is 1/10? What is 1/10 of 1 million? It is 1 times 10 to the power 5. Now class, that is still a lot of bacteria. Another 1/10 dilution brings us to 1 times 10 to the power 4 bacteria. That is now 10,000. That is still too much to count, too many to count on an agar plate. So this 1 times 10 to the power 3, that is 1,000 bacteria. 1,000 bacteria. Yo, I cannot count 1,000 colonies on an agar plate. Now, if I go to this one, a further 1/10 of this is 1 times 10 to the power 2. 1 times 10 to the power 2. And that is 100. Yes, on that petri dish, I am capable of counting 100 colonies. Okay. Now I'm going to my last plate, and if this one is giving 100, then this one must give us 10 colonies. You see there, they give us 10 colonies. Now we can calculate. Take now 10 colonies in a 10 minus 6 dilution. How? How will you calculate it? How many bacteria was in the original sample? Very simple. Very simple. All you do, take the minus away. So 1 times 10 to the minus 6 bacteria per mole. Check here. If I say to you, class, there is 10 bacteria in a 10 minus 5 dilution. In a 10 minus 5 dilution. Okay. So, then, in my original sample, I've got 10 times 10 to the power 5 bacteria per mole. That's it. That's it. All I do, I take the minus of the dilution away. Now 10 to the power 5 is the same as 1 times 10 to the power 6. And that was what was in our original sample. Okay. Class. This thing, you will use it a lot. Especially when we're coming to pour plates and spread plates, you will need this a lot. But I can tell you in what is happening, that you will find that no method is 100% accurate. What is going to happen? Let me show you. What is going to happen is that in the 10 minus 4, 10 minus 4, 10 minus 5, 10 minus 6 dilution, you're going to count here, let's say, 330 bacteria. Here you're going to count 20 bacteria. Here you're going to count 5 bacteria. You see, now never you will get exactly as I showed you now. So here's a good example. 10 minus 4, I counted 330 bacteria. I counted in the next one, 10 minus 5 dilution, I counted 20 bacteria. I counted in 10 minus 6, 5 bacteria. I always try to work out, I always try to calculate the average. The average. How do I do that? 330 times 4, 10 to the power 4 bacteria per mole. 20 times 10 to the power 5 bacteria per mole. And the last one is 5 times 10 to the power 6 bacteria per mole. Like that. I'm sure you can calculate the average here. How can I calculate the average? Let me show you quickly. You will agree with me that 3,3 times 10 to the power 6 bacteria per mole. The next one is 2 times 10 to the power 6 bacteria per mole. And the last one is 5 times 10 to the power 6 bacteria per mole. Okay, I count it up. Is 5 for 7 is 10,3. 10,3 times 10 to the power 6 divide by 3 gives me roughly 3,4 times 10 to the power 6 bacteria per mole. Okay, let me show you. Do you agree? Do you agree? 330 means I've got 330 times 10 to the power 4. I take the minus away. Okay? Bacteria per mole in my original sample. This one says, no, you've got 20 times 10 to the power 5 bacteria per mole in your original sample. And this dilution says, no, you've got 5 times 10 to the power 6 bacteria per mole. Therefore, I had to work out the average. How do I work the average out? Check what I'm doing. Do you agree with me? 330 times 10 to the power 4 is the same as 3,3 times 10 to the power 6. 20 times 10 to the power 5 is the same as 2 times 10 to the power 6. This one is 5 times 10 to the power 6. I add them up, it gives me 10.3. 10.3 times 10 to the power 6 divided by 3 gives me roughly 3,4 times 10 to the power 6 bacteria per mole. See, so it is not easy. It is not easy to get an exact amount of bacteria, but that gives us a good indication of how many bacteria is in that sample. I hope that you guys will check more other YouTube videos and that you make sure you understand this technique, because this technique you will take with you in the future. Thank you.